Hello, ladies and gentlemen, welcome to Denmaloe tutorials. In this lesson, we are going to focus on what we call the Laplace transform of trigonometry. So we are going to start with the Laplace transform of cos AT and also the Laplace transform of sine AT. So here we know that e to the power I theta is equals to cos theta plus I sine theta, but now we are having e to the power I AT, which is equals to cos AT plus I sine AT. But we know that the Laplace transform of e to the power AT is equals to 1 over s minus a. But now we are having the Laplace transform of e to the power I AT, which is representing the Laplace transform of cos AT and I sine AT. This is e to the power AT. So here we are going to say is equals to 1 over s minus I a, and then here we know that our denominator is not allowed to left with this complex, so we have to rationalize our denominator, thereby multiplying by s plus ia, s plus ia, and then our answer here is going to be equals to s plus ia over s squared minus I squared a squared, which is equals to s plus ia over here I squared is -1, so we are going to left with s squared plus a squared. Then we can separate the fractions and left with s over s squared plus a squared plus ia over s squared plus a squared, and this one is cos, and then this one ia over s squared plus a squared is for sine AT. So it means the Laplace transform, so solution here, it means the Laplace transform of cos AT is equals to s over s squared plus a squared, and the Laplace transform of sine AT is equals to a over s squared plus a squared. And then let us also look at the Laplace transform of sine and cosine. We'd like to also look at the Laplace transform of cos AT, and also the Laplace transform of sine AT. So here we know that cos theta is equals to e to the power theta plus e to the power negative theta all over 2. So here we are going to transform, and then we are going to use our Laplace transform, which is f of s is equal to the integral from 0 up to infinity of e to the power negative s t f of t dt. So here we're going to say the integral 0 up to infinity of e to the power negative st. Then on f of t, you're going to start with cos at dt. And now we are knowing that 0 up to infinity to the power negative. See, and now we are knowing that this cos at is the one which is going to be represented by this. But now we are not having cos theta, but we are having cos at. So it means where here on the power, so we are having theta, we are going to replace with at. So it means here we are going to replace with e to the power at plus e to the power negative at over 2. And then we can solve what we have in the brackets, theta, then e multiply with another e, you can get plus at plus e minus st minus at all over 2 dt. And now we can factor out our half, and then we're left with e the power negative s minus a plus e to the power negative s plus a dt. And now we can solve our integrals now. Then so we can say the integral 0 up to infinity of e to the power negative s minus a multiplied by t, then plus another integral of 0 up to infinity. We'd like to separate these two, to power negative s plus a power t dt. So now it's equals to, then we can write our half here, and then if we integrate here inside this bracket, we are going to left with e the power negative s minus a t all over negative s minus a with our lower limit 0 up to infinity here, plus what we are going to get here, e to the power negative s plus a to the power t all over negative s plus a, s strings lower limit 0 up to infinity. So we are going to left with negative. We're going to factor out negative at the first here. We're going to left with a negative 1 over s, and then we leave e the power negative s minus a there with our limits 0 up to infinity, and then there now we get a negative here, so it means you're going to left with a negative 1 over s plus a, and then in the brackets you're going to left with e the power negative s plus a lower limit 0 up to infinity. So finally we're going to left with negative 1 over s minus a at the first bracket. If we substitute infinity here on t, we're going to left with both this infinity is going to dissolve here, and then we left with e to the power negative infinity, and then e to the power negative infinity is equals to 0 minus, and then if we substitute a 0 here, it means here we're going to left with e to the power negative 0. So e to the power negative 0 is 1. So we're going to left with 1 here minus 1 over s plus a, and then if we substitute infinity here on t, if we substitute infinity here on t, again also to left with 0, and then if we substitute a 0 here, we're going to be left with 1. So if we multiply with this, if we let this one to enter in these brackets, we're going to get a 0 here, and then left with 1 over s minus a, and then this 1 over s plus a, here we get a 0, here we're going to get a positive 1 over s plus a. Then after that, we can find the denominator of these two in the brackets. Then we can say half, and then the denominator, we're going to get s minus a of s plus a, all over. Then on top, we're going to left with, if we say this s minus a into this denominator, we're going to left with s plus a plus, if we say this s plus a into this denominator, we're going to left with plus s minus a. And here you're going to see that this one, this a and this will cancel, and then you're going to left with 2s over, and then here we can simplify this bracket. S multiplied by s is s squared, negative a multiplied by positive a is negative a squared, and then don't have to forget our half, and then this half is going to cancel with this one. So our final answer is going to be s over s squared minus a squared. This is the Laplace transform of cos 80. So next, let us look at the Laplace transform of sine 80. Let's look at the Laplace transform of sine t. So with sine 80, so the Laplace transform of sine 80, we know that e to the power theta minus e to the power negative theta over 2 is equals to sine theta. But now we are not having 80, we are not having theta, we are having 80. So it means we are going to say sine 80 is equals to e to the power 80 minus e to the power negative 80 all over 2. So we can introduce our formula for Laplace transform, which is f of s is equals to the integral up to infinity of e to the power negative st f of t dt. And now we say 0 up to infinity of e to the power negative st. Then on f of t is where we are having sine 80 dt. But we know that sine 80 is the one which is being represented by this. So we can take this exponents here, say e to the power 80 negative e to the power negative 80 over 2 dt, and then equals to 0 up to infinity, and then we can multiply each in this brackets by e to the power negative st, and then we are going to be left with e to the power negative st plus 80 and negative e to the power negative st negative 80 4 over 2, and then dt we can factor out a half, and then left with 0, the integral 0 up to infinity of e to the power negative st plus 80 negative e here to the power negative st minus 80 dt. And now I would like to put an integral also here. So we say the integral of 0 up to infinity of e to the power negative s minus a t minus the integral of the lower limit 0 up to infinity of e to the power negative s plus a of t dt, and we can integrate in our first integral here. Our answer is left with e to the power negative s minus a. We divide by negative s minus a. Our lower limit is 0 up to infinity. Then we say negative. Then here, if we integrate here, we're going to left with e to the power negative s plus a for t, and then here we're going to left with the negative s plus a. So negative by negative, we're going to get a positive here with a lower limit of 0 up to infinity. And then here we're going to leave a half here, and then we can factor out negative 1 over in the first bracket here s minus a, and then we left in the bracket e the power s minus a to the power t with lower limit of 0 up to infinity plus 1 over s plus a. Then the brackets are going to left with e to the power s plus a to the power t, lower limit 0 up to infinity. Then we'll close our bracket here, and then say half. Then now on the first one, let us first write 1 over s minus a, and then if we substitute infinity here, we're going to get a 0 minus, if we substitute a 0 here, we're going to get 1, then plus 1 over s plus a. If we substitute an infinity here, we're going to get a 0 minus, if we substitute a 0 here, we're going to get a 1, and then we're left with half. Then if we multiply with this 1 over s minus a, negative 1 over s minus a, then we are going to left with a 0, and then they're going to left with 1 over s minus a, negative 1 over s plus a. And then now let us find our denominator. Like to simplify this way from the brackets. Then we're going to find our denominator is s minus a and s plus a. Then if we divide with this one, we're going to leave with s plus a negative. Then if you divide with this one with, we're going to left with s minus a, and then our answer here, we're going to say s plus a minus s plus a, or over here we're going to say s squared negative a squared. So here we're going to see that this s and this s is going to cancel, and then we're going to left with negative 2a over s squared a squared here, and then these are 2 cancels, then our answer is going to be left with s a over s squared minus a squared. This is the Laplace transform of Sine AT. Thanks guys for watching. Don't forget to subscribe, like and share.